Hello students, welcome to the quick solutions of All India ACAS Test Series Medical 2019 for the test 4 code ENF and physics subject. The test date was 20th January 2019. Let's start with question number 1. In question number 1, it says that which of the following option is incorrect. So basically we have to choose incorrect option. Option number 1 says transverse waves propagate inside a fluid. We know that transverse wave can only propagate inside a fluid, only longitudinal wave can travel. So option number 1 is the wrong one. Option number 2 says a wave transports both energy and momentum. Yes, this is the definition of the wave. Wave is the propagation of energy and momentum. So this is our true. Option number 3 says only mechanical wave require an elastic medium for their propagation. Yes, we know that non-mechanical waves does not require any medium and mechanical waves requires an elastic medium for their propagation. So this is also true. Option number 4 says longitudinal waves can propagate through any medium. Yes, longitudinal wave can propagate through solid, liquid and gases, any medium, right? So this is also true. So from this we can say that our option number 1 will be the correct choice. Now let's move to the question number 2. In question number 2, it says that the RMS speed of the molecules of a given mass of an ideal gas increases when. So we know that the RMS speed of the gas molecules is given by the formula Vrms is equal to root under 3RT by m. So Vrms will increase only when the temperature will increase, right? Because Vrms is directly proportional to square root of the temperature. So when the temperature will increase, the Vrms will increase. Now let's look at the options. First option says pressure increases at constant temperature. Since the temperature is constant, so Vrms will not increase. So this is a wrong. Second, volume increases at constant temperature. Again, temperature is constant. So since the temperature is constant, Vrms will not increase, right? Pressure increases at constant volume. We know that at constant volume, for constant volume, pressure will be directly proportional to the temperature, right? So when pressure increases, temperature will also increase. So yes, Vrms will increase. Now option number 4. Temperature decreases. When the temperature will decrease, Vrms will decrease. So our correct choice will be option number 3. Let's move to the question number 3. In question number 3, it says that select the correct option. So we have to choose the correct one. First option says that the average translational kinetic energy of an ideal gas molecules depends on temperature and its nature. So we know that there is 3 degrees of freedom for translational motion, right? 3 translational degree of freedom. We know that 3 translational degree of freedom for any molecule. And for diatomic, there will be 2 rotational. For monatomic, 0 rotational. And for polyatomic, 3 rotational. So rotational degree of freedom changes according to the nature. That means for monoatomic it will be 0, right? For diatomic it will be 2, right? And for polyatomic it will be 3. So we can say that our degree of freedom changes according to the number of atoms, but only rotational degree of freedom. The translational degree of freedom is fixed for every molecule, right? And we know that for each degree of freedom there will be half kT energy. So we can say that total translational kinetic energy will be equal to 3 by 2 kT, right? Because there is a 3 degree of freedom translational. So this will remain for every molecule. It is independent of its number of atom, right? So according to the question, it says that the average translational kinetic energy of an ideal gas molecules depends on temperature and its nature. No, it does not depend on its nature. It only depends on the temperature. So this is our wrong statement. Second option says that the average translational kinetic energy of an ideal gas molecules depends only on its temperature and is independent of its nature. Yes, this is a correct statement. Now option 3 says the RMS speed for all ideal gas molecules is same at same temperature. No, we know that the RMS speed depends on the molecular weight of the gas also, because it is 3RT by capital M. So for all ideal gas it will not be same, it will depends on the molecular weight, and since the gas changes, molecular weight changes, so the RMS speed will not be same. So this is our wrong statement. Fourth option says that the average translational kinetic energy per molecule of oxygen gas. So again, it is oxygen, hydrogen, helium, whatever it is, translational kinetic energy per molecule will be 3 by 2 kT, because translational degree of freedom is 3 always. So this is also our wrong statement. So our final answer will be option number 2. Let's move to the question number 4. In question number 4, it says that a graph is plotted with PV by T on y-axis and mass of the gas along x-axis for different gases. The graph is, so we know that PV will be equal to nRT for any ideal gas, right? So we can write PV, N will be what? N is the number of moles. So can we write the N will be equal to the total mass divided by molecular weight into RT. So we can write PV by T will be equal to total mass into R by capital M, right? So according to the question, it says that a graph is plotted between PV by T on a y-axis. That means this should be taken as y, and mass of the gas along x-axis. That means this should be taken as x. So if I take y is equal to x, so this whole quantity will give you the slope of the line. Y is equal to mx, right? So we can say that our slope of line will be equal to R by M. And since there is no constant here, so this whole line will pass through origin. So now let's look at the options. Question says that a parabola passing through origin. So this will never be possible, right? Second, a straight line passing through origin with a slope having different values for different gas. Yes, this is a straight line passing through origin, but slope is equal to R by M. So we know that for different gases, the molecular weight will be different. So the slope will be different. So yes, this is the correct statement. Third option says that straight line passing through origin with the slope have same value for different gas. No, this is wrong. Straight line with positive intercept. No, there is no intercept because this constant is 0. So this is also wrong. So we can say that our option number 2 is the correct choice. Now let's move to the question number 5. In question number 5, it says that select the correct option. So we have to choose the correct option. First option says speed of sound in gas is equal to root under gamma by 3 times RMS speed of gaseous molecule. We know that the speed of sound in any gas will be equal to root under gamma RT by M. And the RMS speed of gaseous molecules can be written as root under 3RT by M. So if I divide velocity of sound with RMS speed, since RT by M is same, they will cancel out. So only remaining thing will be gamma by 3. So yes, our option number 1 is the correct one. Now let's move to the option number 2. Option number 2 says average speed is greater than RMS speed is greater than most probable speed for ideal gas. So we know that the average speed of any ideal gas molecules will be given by 8RT upon pi m, and the most probable speed for any ideal gas molecules will be given by 2RT by m. So as you can see that the RMS speed has a coefficient 3, average speed has a coefficient 8 by pi, and most probable speed has a coefficient 2. So from this we can say that our VRMS will be more than V average, will be more than V most probable. So from here we can say that our option number 2 is the wrong one. Now let's look at the option number 3. Option number 3 says most probable speed is equal to root 3 by 2 RMS speed. So if I divide most probable speed by RMS speed, how much you will get? So since most probable has a coefficient 2 here and the RMS has a coefficient 3 here, so we can say that this will be equal to root under 2 by 3. But here it is 3 by 2 is given. So this is also wrong. So from this we can say that our option number 1 will be the correct choice.